Not every star gives life. Some take it away. And the closest one to us might be the most dangerous of them all.
In the silent depths of space, a faint red star drifts, quietly hiding a reality far more dangerous than it appears. Just 4.2 light-years away, this distant star sits closer than any other, quietly watching from the edge of our cosmic neighborhood. Despite its proximity, it remains invisible to the naked eye, lost in the darkness of the southern sky. Around this dim star, planets move in silence, worlds that once carried the possibility of life beyond Earth. One of these planets, Proxima b, orbits within the habitable zone, where liquid water could exist under the right conditions. But as we study this system more closely, that fragile hope begins to fade under a far more hostile reality. First identified in 1915, this star was once considered an unimportant point of light in the vastness of space. For decades, it remained a forgotten object, too dim and distant to capture serious scientific attention. That changed in 2016 when astronomers uncovered something that would completely transform how we see this system. They discovered an Earth-sized planet orbiting in just the right place, where temperatures might allow liquid water to form. For a moment, it seemed like the perfect candidate for life, a nearby world that might not be so different from our own. But beneath its calm appearance, this star hides a violent nature that changes everything we thought we knew. Proxima Centauri is a red dwarf much smaller and dimmer than our Sun, yet far more unpredictable in its behavior. Stars like this dominate the Milky Way, making up the majority of stellar systems scattered across our galaxy. And if this star is any indication, many of those worlds may be far more dangerous than we ever imagined. Red dwarfs like Proxima Centauri are incredibly dim stars, releasing only a tiny fraction of the energy our Sun produces. Because of this low energy output, the habitable zone exists extremely close to the star, almost uncomfortably near. Proxima b orbits at a distance of just 7.5 million kilometers, placing it dangerously close to its host star. For comparison, Mercury orbits our Sun much farther away, making Proxima b's position feel extremely tight and exposed. At such a close distance, the planet is almost certainly tidally locked forever, showing only one face to its star. One side is trapped in endless daylight, while the other remains in permanent darkness, creating an extreme planetary divide. The temperature difference between these two sides could reach hundreds of degrees, making survival incredibly difficult in most regions. On the dark side, you would live your entire life without ever seeing the star that gives this world its energy. Step onto the bright side, and you would face relentless radiation, pouring down from a star that never truly rests. Some scientists believe a narrow twilight zone between light and dark could offer slightly more stable and tolerable conditions. In theory, a thick atmosphere could redistribute heat, softening the extremes, and allowing more balanced temperatures across the surface. But that possibility depends on one critical factor: whether the planet can actually hold on to its atmosphere at all. And this is where Proxima Centauri reveals its true nature, as a highly active and dangerously unstable flare star. Its magnetic field constantly twists and snaps, releasing massive bursts of energy in violent and unpredictable eruptions. Unlike our sun, these eruptions happen frequently, turning this quiet-looking star into a constant source of powerful cosmic storms. Proxima Centauri doesn't just flare occasionally, it erupts constantly, releasing sudden bursts of energy that can overwhelm everything nearby. In 2016, astronomers witnessed something shocking, a powerful flare that pushed this small star far beyond expectations. The star's brightness suddenly increased by a factor of 68, turning a faint object into something briefly visible. For a few seconds, this normally invisible star became bright enough to be seen without any telescope at all. But what made this event truly terrifying was the sheer amount of energy released in such a short moment. That energy translated into intense ultraviolet radiation, blasting directly toward Proxima b with devastating force. The radiation from a single flare was strong enough to destroy even the most UV-resistant life forms known on Earth. In fact, it delivered nearly 100 times the lethal dose required to kill the toughest known microorganisms. And this wasn't a rare event, because Proxima Centauri produces these powerful flares multiple times, every single year. Over time, repeated exposure to such radiation begins to slowly break down the planet's protective atmospheric layers. Within just a few years, most of the ozone layer could be destroyed, removing the only natural shield against harmful radiation. Without that protection, every new flare strikes the surface directly, bathing the planet in intense and deadly ultraviolet light. The planet is left under constant attack, with no time to recover before the next wave of radiation arrives. Then in 2019, an even more powerful flare was detected, far stronger than anything scientists had ever recorded before. In just a few seconds, the star unleashed an enormous burst of energy, dwarfing even the most extreme solar events from our sun. During this event, the star's ultraviolet brightness increased nearly 14,000 times, creating one of the most violent stellar outbursts ever observed. This single flare was around 100 times more powerful than anything our own sun has ever produced. For the first time, scientists captured this flare across multiple wavelengths, revealing new details about how these eruptions behave. They discovered unusual radio signals, rising and falling alongside ultraviolet radiation, hinting at complex physics still not fully understood. What makes it worse is that events like this may not be rare, but could be happening as often as every single day. This means the planet is under near constant bombardment, with powerful flares striking again and again without any real pause. Under such relentless exposure, the surface becomes an extremely hostile environment, where survival becomes nearly impossible. But flares are only part of the danger, because the star also releases a continuous stream of charged particles. This stellar wind flows outward, constantly carrying high-energy particles that directly interact with anything in its path. On Earth, our magnetic field deflects most of these particles, protecting our atmosphere from serious damage. But Proxima b orbits much closer, where the pressure from this stellar wind is thousands of times stronger. Without strong protection, these particles slam directly into the planet, slowly stripping away its atmosphere over time. Light gases escape first, but they drag heavier elements with them, gradually eroding everything the planet needs to survive. Over millions and billions of years, this process can transform a once promising world into a dry and lifeless wasteland. Even with a magnetic field like Earth's, the damage may still be too extreme for the planet to hold on to its atmosphere. Early in its life, Proxima Centauri was far brighter and hotter, creating conditions even more extreme than what we see today. During this early phase, the habitable zone existed much farther away, leaving inner planets exposed to intense heat. Any water that once existed on Proxima b would have likely boiled away, long before stable conditions could ever form. By the time the star settled down, the damage may have already been done, leaving the planet dry and lifeless. Proxima b is not alone as another planet. Proxima d orbits even closer to the star in extreme conditions. This smaller world completes an orbit in just a few days, placing it dangerously close to intense stellar radiation. Temperatures on this planet are far too high for liquid water, making it completely uninhabitable by known standards. Farther out lies Proxima c, a much larger world, orbiting in a colder and more distant region of the system. But at such a distance, temperatures drop far below freezing, making liquid water nearly impossible to sustain. In this system, the inner worlds burn under radiation, while the outer ones freeze in darkness, leaving no perfect balance. It feels almost like a trap, where every possible condition for life is carefully broken, in one way or another. Still, some scientists believe there may be small chances, where life could survive under very specific conditions. Life might exist underground, hidden beneath the surface where radiation cannot easily reach. Similar to icy moons in our solar system, subsurface oceans could provide shelter for simple forms of life. But such life would remain hidden, completely invisible to our telescopes, and beyond our current ability to detect. Red dwarf stars like this dominate our galaxy, meaning billions of similar worlds may face the same harsh reality. If these conditions are common, many planets we once considered habitable may actually be completely lifeless. Observations of other flares happen frequently, already suggest that many of these under constant environmental have lost their atmospheres entirely. This creates a world where conditions never stabilize, long enough for life to begin or evolve. Future telescopes may finally reveal whether Proxima b still holds any atmosphere, or has already lost everything. If no atmosphere is found, it would confirm one of the most important lessons about planets around red dwarfs: that even worlds in the habitable zone can become completely uninhabitable under the wrong stellar conditions. Proxima Centauri will continue burning for trillions of years, long after our sun has faded away. While our solar system eventually dies, this small star will still remain active and violently unstable. Despite its dangers, humanity still dreams of reaching this nearby system within a single lifetime. Because it is close, it is reachable, and it offers us a rare chance to study another world in deep detail. But what we are learning is clear: proximity, sadly, does not mean safety, and closeness does not guarantee life. The search for life may lead us farther away, toward quieter stars where planets can survive long enough to evolve. Proxima Centauri is not a beacon of hope, but a warning about the dangers.
Thanks for watching. For more amazing space facts, subscribe to Planet Facts and don't forget to hit the bell icon to stay updated.